All right, let's dive into phase 4 of the CPMI methodology. We're talking about AI model development. Now, a lot of people think this is where the magic happens, right? Where some kind of digital intelligence is just created. But the reality? It's much more like trying to navigate a really complex maze, where every single turn you take is a critical decision.
So, how are these things really built? I mean, how do you go from a cool idea to a working AI model? You can forget that stereotype of a lone coder pounding away at a keyboard in a dark room. The real process, well, it's way less about just typing code and much more about smart, strategic navigation.
I want you to really think about it like this. Every choice you make, the algorithm you pick, the data you decide to use, that's a turn in the maze. And if you make a wrong turn early on, you could hit a dead end fast. The goal isn't just about getting to the end, it's about finding the absolute smartest, most efficient path to get there.
Now, getting through this maze used to be this grueling, totally manual process. But today, we've got some incredible shortcuts, and I'd even call them superpowers, that have completely changed the game. It's all about working smarter, not harder.
So our first superpower is something called AutoML, which stands for Automated Machine Learning. Think of it like a seasoned guide for the maze who automates all the most tedious, time-consuming parts for you. And what this does is it opens the door for what we call citizen data scientists, people who have deep knowledge of the business but maybe not the deep coding skills, to actually build some really powerful AI models. And this image, it really says it all. The path on the left, that's the old way, a slow, painful slog with a ton of trial and error. But on the right, that's the AutoML approach. It just systematically tests all the different paths for you, finding the most efficient route and pretty much getting rid of all the guesswork. This brings us to a huge strategic choice you have to make. Do you build or do you buy? You could build a totally custom model from the ground up, maybe using AutoML to make it faster. Or you can buy by using a pre-trained model from a third-party service. This is a massive decision point in any project.
And that buy option, it's more powerful today than it has ever been. I mean, you can now tap into these enormous, pre-trained foundation models that already have a deep understanding of language and concepts. Then you can fine-tune them for your specific needs, or you can leverage generative AI just with clever prompting, or you can even chain different models together. This is where the real speed is these days.
Well, let's make this a little more real. So Coca-Cola needed to moderate content for one of its social media apps. Now, instead of spending months and a ton of money building their own image recognition model to find inappropriate content, they just used a pre-trained, off-the-shelf model. And that move saved them a massive amount of development time and resources. That's the power of the buy approach right there. Okay, so with all these powerful tools out there, how do you actually make the right choice? Well, that brings us to the critical checklist. These are the key questions your team absolutely must answer before you even think about writing a single line of code. So here they are, the 4 core decisions. First up, which algorithms can actually solve your problem? Second, how are you going to use shortcuts like AutoML and pre-trained models to speed everything up? Third, what specific software and platforms are you going to use? And finally, number 4, where will you do the really heavy lifting, the training? On your own servers or in the cloud? Every single one of these choices has huge implications for your budget and your time. Take a look at NASA's project to predict aircraft engine failures. Their goal was simple. Will this part fail soon? That's a yes or no question, and that directly pointed them to a classification model, which is designed to sort things into neat categories. Now, if they had asked how many hours until it fails, they would have needed a completely different type of model, a regression model, which predicts a number. You see, the business need always drives the technical choice. This leads to a total shift in how we think about this. The default question isn't, should we use a pre-trained model anymore? The question you have to ask now is, why on earth would we not use one? If you're planning to build from scratch, you better have a really, really good reason for it. Seriously, this justification step is basically mandatory now. It forces your team to prove they aren't just reinventing the wheel. It makes sure that your valuable time and money are spent on solving problems that are unique to you, not problems that have already been solved by someone else. Okay, so you've done all that work, and now you have a model. But you've just arrived at a critical crossroads. Do you move forward to the next phase, or is it actually time to go back to the drawing board? At this moment, this is the only question that matters. I mean it. Forget how cool the technology is or how clever the code is.
Does the model actually do what the business needs it to do? Does it solve the problem you set out to fix all the way back in phase one?
This right here is the go/no-go moment for this entire cycle of the project. And it's not just a technical check. It's a huge strategic decision that determines if you're going to invest more time and money moving forward or if you're going to save those resources by taking a step back.
You know, it's so tempting to just push forward, to hope that things will magically get better in the next phase. But let me tell you, if your model isn't hitting its performance targets now, charging ahead is the absolute worst thing you can do. It's like deciding to build the rest of a house on a shaky foundation.
This iterative loop is so key. A problem you find right now often points to an issue in a much earlier phase. So for example, if the model's quality is just poor, the root cause probably isn't the model itself. It's likely your data prep back in phase 3. If the model is failing to meet your business KPIs, you might have to go all the way back to phase 1 and ask if you're even solving the right problem to begin with.
And this right here is probably the most important thing to remember. Going backward is not a sign of failure. It is a planned, strategic, and essential part of the process. Finding a problem and having the discipline to course correct, that's how successful AI projects are actually built. It's not a bug, it's a feature of the whole methodology. So, when you boil it all down, the mark of a truly expert AI team isn't just their ability to build something, it's the wisdom to know when to stop and rethink, and the courage to go back and get it right. It's all about being ready to loop. So the question is, are you?